everybody. And as promised, you are up for a really, really great experience. It is my honor to introduce our next presenter. He is someone that amazes all of us here at Crane. However, outside of this community, he has logged in over 86 hours of volunteer time and was just named the Volunteer of the Month at the Santa Barbara Sea Center, and that was out of 270 volunteers, I'll have you know. So, please welcome our very own science scholar, 5th grader, Ian Shisha.
For giving me the time to make this possible. Let's get started. We normally only get to see pictures of carnivorous plants, such as Venus flytraps, but today I happen to have brought a real one. It's the largest variety ever discovered. Behold! It is the largest variety, but most are only about this big. However, movies like this one, like the one on the screen, love to exaggerate them. There are many other species of carnivorous plants. Let's dig a little deeper. Now you may be wondering, aside the fact that it's pretty cool, why a plant would want to be carnivorous, which by the way means that it eats animals and meat. I mean, why spend time and energy trying to catch something that moves and thinks if you can do neither? Doesn't seem like an even match. Well, it turns out it's because carnivorous plants live in places where it's boggy, swampy, and marshy, and the soil doesn't have many. Turns out that's actually not much. It's many nutrients. So they take vitamins in the form of insects. You may have heard of this one, the Venus flytrap, before. It used to be thought that the lobed blades closed as soon as one of the trigger hairs was touched. However, new studies show that the blades only close after the trigger hairs are touched 3 times in 30 seconds. That way, the plant knows that its catch hasn't flown away and it doesn't waste energy in failed attempts. This data shows that, in a sense, some plants have basic counting abilities. Here it is again in slow motion. You can see the beetle is already on top of one trigger hair, and here it kicks out and hits the other 2. Historically, Venus flytraps have lived all over eastern North and South Carolina, which isn't much, but now, due to habitat loss, they've become increasingly more endangered. Though they live elsewhere, the only place where they still live successfully in large numbers is the green swamp off Myrtle Beach. This is the best place to see many different species of carnivorous plants. The picture on the left is of yellow pitcher plants, which also live in the green swamp. These are the largest species of pitcher plant and can grow up to 1 meter or 3 feet. It's a common misconception that the rain covers close to catch insects in the tube. Here's actually how it works. Insects attracted to the sweet scent released by the rain cover land on the rim expecting nectar. Not finding any, they creep farther down, hoping to find food, but the walls are very slippery, so they lose their grip and start to fall. The farther down they go, the more slippery it becomes, until the unfortunate insect lands in the liquids at the bottom. Downward-facing hairs prevent it from climbing out. Eventually, the insects drown and get digested. All very pleasant. Many different animals have taken advantage of the bounty captured by pitcher plants. Pitcher plant ants, for example, live inside the pitcher plant's vine and eat the insects that it has captured. They use surface tension to walk on the walls without slipping. You would think that the pitcher plant wouldn't like having its food stolen and its support vine drilled through, but it turns out it actually is the better end of the deal. The parts of the insects that the ant take the pitcher plant cannot digest, which actually having them cleaned out. Also, the ants attack mosquito larvae and guard the plant from different animals that might steal its catches. Finally, the pitcher plant gets extra nutrients from the ant's feces and the ants that die naturally. Just recently, scientists found this bat the Hardwick's woolly bat living in one type of pitcher plant in Borneo. The pitcher plant doesn't smell as strongly and is shaped differently, so it only catches 1/7 of the insects than other species do. However, its shape allows so that the bat's calls echo extra loudly so it can be found more easily. Its shape also allows so that the bats do not get wet. In return, the pitcher plant feeds on the bat's nutrient-rich guano, which is their poo. There are many different other species that rely on the pitcher plant, from shrews to spiders, but I don't have all day, so let's move on. This is my favorite species of pitcher plant. It's called the cobra lily. I'll let you guess why it's called that. After flying in through the mouth, the flies find up on the dome floor where they cannot see how they got in. They can't see, however, the light spots on the top of the dome, which it assumes are the holes that lead out. When it flies up, it runs headfirst into the side of the dome. Confused and unsteady by the blow, the fly flies down right into the water, which is why we never let flies pilot planes. Okay, that was a lot on pitcher plants. Moving on to sundews. At first, it just looks like a cactus covered in the morning dew. Then, knowing that carnivorous plant, you might think it's a simple fly paper trap, but when showed in time lapse. Play video, please. The sundew eventually wraps around its tail like a snake and digests it. Butterworts follow a similar strategy, except the edges of the leaf curl up instead, so they can release juices to digest their prey. They are very effective. Bladderworts, not to be confused with butterworts, make excellent koi palm plants. They have bright yellow flowers and an intricate root system holding them up. The roots are covered with these tiny sacs. When small pond animals, such as something called a rotifer, touch the trigger hairs in front of the trap door, the door instantly swings open, the walls of the sac expand, forming an extremely strong and fast sucking motion to suck in the prey. If this sounds familiar, that's because frogfish use the same mechanism.
What?
I always love that. So here it is in action. It's much too fast to see. Here it is again in slow motion. Watch the trap door right here. I should also give a brief mention to water wheel plants, which is a technique similar to that of Venus flytraps, except they live underwater. And to the Genlesia family, which make very complicated lobster pot-like traps. But plants are the only unexpected carnivores. This zoophagous fungus is essentially going deep water fishing. It sends off little sprouts from the main line. When an animal such as a rotifer bites the new greenery, the sprout instantly swells up inside its mouth so it can't let go. The fungus then proceeds to eat the rotifer from the inside out. Finally, this dactylia fungus captures worm-like nematodes and snares. As soon as one of the snares is touched, 3 cells around the edge swell up. No one has yet filmed a nematode actually activating one of the snares. But who knows? Maybe someone in the audience will be the person to do it. I hope so. Thank you. If you have any questions or want to come up afterward to see the Venus flytrap, please do.
Yeah, I mean, Ian, can I ask you,
Yeah?
do you happen to know when you first, got interested in science?
It was about, I think about 7 months.
7 months old?
7 months.
I can see that. We are so lucky to have this kind of curiosity and funniness. Very